Today I'm turning this flexible PCB into a speaker. That's right, we can make speakers out of PCBs. And this is actually not new. And these are actually called planar speakers. Because they are planar. Here I have a commercial planar speaker. And believe it or not, this cost me almost $40. So can we make it cheaper? In the past I've made these headphones with planar speakers. But today I want to try something different. Can we make enough power for some normal speakers, not headphones? I've played around with the settings for the flexible PCB, decreasing its impedance, and I also want to try some techniques for making the enclosure of the speaker. So if this sounds interesting, stay till the end. That being said, let's get started. What's up my friends, welcome back. As before, the main component for such a speaker is the flexible PCB that I've designed. It might look the same as the previous one, but actually this is a bit different. I played around with the configuration of the coils and also the thickness in order to reduce its impedance. Actually, I've played around with the shape, with the overall shape of the entire membrane, and stick with this one.
In Altium, I create a new PCB file, and using the arc tool, I first create the PCB outline with a radius of 38 mm. Then I use the via tool and add 8 vias all around. I change their size to 3 mm and adjust the position. Then using the routing tool I create the loops. I've made 15 loops. And finally I add some details and export the PCB. It's so easy to work with Altium.
Once I have only one layer of the PCB, you can just download the Gerber files, send them to pcbway, and the designing process was very easy because it's quite a simple design. And please comment below if you would like me to make a full tutorial about Altium and how easy it is to work with, and yeah, if I should make a full tutorial. Okay, once you have the Gerber files, you go to pcbway.com and select the flexible PCB, which is this one here, and you code now. And you add the settings. For example, is 76 by 76 in width and height. And for the pieces, I will just select 5. For the rest of the settings, I will leave it as it is. For the flexible PCB, this is the one that I'm getting. Not the rigid flex, but the flexible PCB. They will turn great with PCBway. We save to cart. And here, select the Gerber files that you have just downloaded from Altium. And here it is. I select it, upload it, submit the file. Now that the Gerber files are uploaded, it will be approved by an engineer. I'll make the payment, and in just a few days, I'll receive the PCBs for my great project. So it's that easy to order from PCBway. Okay, so now I have the new PCB, but the 3D printed support was also updated. And that was thanks to some comments from you guys actually. First of all, now the parts are printed with resin to have some more details, but you can also use an FDM printer. And now I've added this bulge here and a groove on the other side. In that way, it will make some pressure on the flexible PCB, tighten it up all around the perimeter, because it's very important to have a very tight membrane. Otherwise, in the previous design, I had this membrane here not that tight and it was vibrating too much, touching the walls, making some noise, vibrations, and resonate too much. So now that I have this bulge here and a groove on the other side, it will apply a constant force all around the perimeter, tightening the membrane up. Very clever idea, thanks to some comments from you guys. So download the 3D files from below and use a resin printer to make these parts. You don't need supports or anything. And if you don't have a resin printer, you could also use an FDM printer because the results are quite close. You get more details with this, but anyway, you can use an FDM printer if you want and get the 3D printed part. So now we are ready to assemble this. For the magnets, I'm using the same magnets as before, which are 48 by 4 mm neodymium magnets, very strong. In my case, I have 4 parts because I'm planning to make a bunch of speakers to test them out. I'll make like 2. And yeah, get the membrane, magnets, and the parts. And I will use some super glue to glue this into these parts. Obviously, alternate the polarity, so south, north. Glue them inside here, and yeah, then we can close it. Okay, now I have the magnets in place with super glue, and now we have to solder the wires, the audio wires, to the PCB, and make sure that you solder with less temperature and also more faster than usual, because this type of flexible PCBs are a little bit more fragile than normal PCBs. So less temperature and faster. Okay, so now we take the membrane, place it on the pins. There you have it, and now we sandwich it in between, making sure that this part is where the wires will go. So just like that, I have the speaker driver. And now we have to talk about the enclosure. So if I want to keep this homemade and low cost, 3D printing the enclosure would be the best option, right? But you see, why just printing like this by itself is not the best option? Because speakers are special. You need to make an enclosure that is airtight and also has mass and also has density, so plastic will resonate and sound a lot. If you check a commercial speaker like this one, you'll see that usually the case is made out of hard wood that has density and a lot of mass. As you can see, it's quite heavy because otherwise it will resonate too much and create a lot of unwanted noise. So a 3D printed case by itself won't do the job for me. So we need to add something more to it. Let me show you. So the best option that I found online that actually works, to my surprise, quite good is to make an empty 3D printed enclosure and fill it with plaster of Paris mixed with some water and, to my surprise once again, white glue. This is the typical glue that you use with wood. This actually, from what I see online, gives one of the best results with 3D printing for speakers. Is actually quite good. So in order to be able to fill this with plaster, I had to make it, as you can see, double wall. And right now it's quite flimsy, but I will fill it with plaster, it will get quite hard. We also have the support. So this, as you can see, is double wall, so you can add the plaster inside of it and get that mass for the acoustics. I've made the same for the walls. As you can see, this will be the walls that will get on top of that. And as you can see, it's also empty inside. So we will fill this with plaster and hopefully that will resonate a lot less and also get the mass for the case that we need. And by the way, I've made this design thanks to the Hexi-based YouTube channel. If you want to check it out, you'll learn a lot about designing and 3D printing speakers with a lot of knowledge, because in my case, I'm not an expert. Actually, my audio levels, audio level for engineering are quite low. I am taking an audio course because I want to learn more about amplifiers and so on, but I'm not an expert, so take this video as a prototype. It's not a professional work. And once again, check Hexi-based YouTube channel if you want to learn more about how to make this kind of speakers. So by learning online and with Hexi-based channel and making the calculations for the distance, what I've understand is that if you want to get more bass or if you want to sum up the waves, actually the sound is just a wave that will travel in that direction. If you have the speaker here, the idea is to add this channel in order to add a delay between this wave here and this wave here. In that way, when the waves will touch each other, will combine, in order to get a destructive combination, you get a constructive combination. So basically the peaks from this wave would be merging with the peaks on this wave. They are both positive. In that way, you get like more bassy sound and more power to the sound. That's the basic idea. So using an online calculator, you can calculate the distance here. And if I were to make like a long tube, it will be easier. But if you want to fit everything inside of a case like this one, you have to make like this, like a snake. And that's why we have all these grooves here. So here will go the speaker and the sound will exit here on the back. So that's basically the theory, but for the practice, we have to test it out. Also, why do we need to add some glue to the plaster? Well, because actually, if you just use plaster, the results are even worse than just using plastic. Because I'm not sure if you ever heard, but plaster is like ceramic. So if you hit it with something hard, it will ring like a bell. If you ever hit a plate made out of ceramic, it sounds very hard. So in order to dampen that sound, we add that glue and makes the plaster like more elastic. So you will see in the results, the difference between with wood and with glue and without glue is huge. Adding glue will change it and make like a perfect insulation for the entire case. So in just a moment, I'll make the mix. So you have to mix the water that says here on the package, but for each 1 liter of water, I will add like 150 milliliters of glue. Basically, like 50% of the water should be white glue, 50 to maybe 20%. And I had to make a few prints, and actually I'm still printing. I'm not sure if you can hear the printer there, because I had some errors with the design. Not errors, but something that I haven't thought. For example, the walls are just 2 perimeters, and as you can see, since they are that thin, they bulged in. I'm not sure if you can see, but it's not straight. So in order to add some more supports to the wall, I've added these very small pillars all around. This is a bad part because I was running out of filament because it was an old filament, and I decided to scrap it out. So we won't use this, but at least this is straight. So we eliminated the bulginess here. So this is the last one that I've used, like a wood PLA. the results are a lot better. But as you can see now, they are straight because we have these pillars here that will keep the entire case in place. But that also makes us lose a little bit of quality. As you can see, this is smooth, but since here we have the pillars, they've added this ghosting effect, so maybe you should sandpaper the case a little bit or add a primer and then sandpaper it, maybe paint it. In my case, before I start adding the plaster, I've added these insertion nuts using my soldering iron because this is where the speaker will go and we need this, and it's a lot easier to add them now before we fill this with plaster. So now just make the paste and add it to the case, also to the walls of the case. Okay, so I finally got to fill it. I had to put it on the ground. It was a mess, so just a tip, this can get quite messy. So you have to make small quantities, and also this will dry quite fast, and you don't have to put too much powder. It has to be a little bit liquid. So yeah, I finally fill it, but now I'll have to clean it once this is dry. And it will dry quite fast. So since I have to work very fast, I was tired working with that small pot there, and I prepare another one. Now I'm using my drill and a mixer, and I'm using a good container for the paste. So yeah, this will be a lot faster. This time the result is a lot better. I had a small hole here which I had to fill with some tape. So now it's filled, it is closed. But as you can see, the paste is a lot smoother. I get till the edge of the 3D printed part. Every side is filled. So now it should dry. And not sure how long it will take. I guess I will have to leave it till tomorrow. Okay, so now I have everything that I need to make this. Now that the cement is dry, I do have two of them, but this, it's a little bit awful. I will have to fill it with silicone, well merge the parts, and I still have to clean them because they're very ugly and full of paste. So I'll have to clean them, maybe polish them a little bit, and maybe even paint them. I have to print it some more supports. This is a frame for the speaker, and this will be the support that will get below the speaker to give them an angle and support the speaker. So now, using some silicone, and I will seal it all around, but actually we first have to add this to the screws and also pass the wire below here. So that's the next step. By the way, now that they were filled, they sound a lot better. They don't sound like an empty plastic container or a tin can anymore. I decided to clean and polish the cases after the glue is dry because it will be like more compact. So now the glue will be drying out. I have some heavy weights on top of them, and I will leave them overnight. And also make sure that you pass the cable before you glue it, because otherwise it will be a lot more difficult to add there. As you can see, I also made a nut, so to make sure that it won't get loose. So this will be soldered to the speaker later. Now we have to wait and then clean them and maybe paint them. But that will be tomorrow. This is the first test. In a moment I'll explain you why we have that awful sound. I also have the sound of the power supply. But yeah, for a small membrane the sound is quite powerful. Yeah, we have that ugly noise. So let me just stop it and tell you what is that noise. I had to change a little bit the design and reprint these parts once again. Now, as you can see, there is some space between the margin of the membrane and the magnets. But now, since I'm working with a lot more amplitude, the tracks are bigger, the membrane will vibrate a lot more and it's touching the magnets. So we need more space, more clearance between this membrane and the magnets. That's why I reprinted this. And as you can see, there is a lot more space. I'll try to place a close-up with the difference between these two. But yeah, there is more space between this, the margin of the membrane, and the magnets. So now I have to move all the magnets on these new parts and reassemble the speaker. So I've changed the design with the new clearance. We have more space. You just hear it here, some of the guitar. It sounds a lot better. Actually, the microphone is here. It it sounds a lot better, but we still have that vibration for the uh, low frequencies, for the bass. So I'm guessing that as a tweeter this will work, or mid-range it would work quite well, but for the bass it still vibrates a lot. The power is a lot higher than the headphones, but still that vibration I don't like it. So guys, here I have the other speaker which I've been sandpaper it and adding some primer because I wanted to paint it, but I did thought to put this project on a pause. Actually, I will repurpose these speakers because the case works quite well and I've worked a lot to make it. But I realized that this was a prototype. I was just trying to see if I can get a lot more sound, but the membrane is very small compared with the speaker. Now for the headphones, I had a very hi-fi sound. The quality is very good and very clear. It's a very clear sound because you have it near your ear. But for big speakers, if we increase the power, increase the tracks as I did with this, as you have seen, we have that vibration, which I don't like. Now, my plan is to make flexible PCBs like this one, but huge, like an A3 format, and make like a planar speaker that could deliver enough power. This, I will still keep this design for my headphones. So if you want to make your headphones or maybe make your own prototype and test it out, you can download this for free from below and order it or at any PCB production site that you want. But for now, I will make this project, I will put it on pause because look how many prototypes I made and a lot more I have in the garbage because I broke them out. So I think that I've made enough tests for this project to, for now, put it on pause and work on a bigger one with a bigger flexible PCB that will be huge, and let this only for the headphones. You have that video below as well. You can download the 3D files for this and make some hi-fi planar speaker headphones if you want. And in my case, it was a good experience. I learned a lot about the audio and what not to do. And by the way, the case is awesome. I mean, it's very strong. It's very thick. The sound dampen is very good. So I want to try this with normal speakers like this one here. I've just ordered some drivers, high quality drivers, and repurpose this, maybe make another hole here or rechange the design and make good speakers using normal speakers, not planar. And for the planar speakers, as I told you, the idea is to make some huge ones. So stay tuned for that. So guys, I hope that you have learned something new about planar speakers and that if you want to get a lot more power, you need a lot more surface area than this. I'll make different options and take this as a prototype. That's why I haven't finished it. And yeah, in my case, I've learned a lot, especially for the case, which it was quite well. I got some good results after a lot of attempts. It was quite messy to work with the paste, but in the end, the case is quite good. But yeah, download my files from below if you want to test it out and make some prototypes. And I really hope that you have also learned something new. That's the main idea of my videos. Thank you very much and keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it. And the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.